Alright guys, so taking a look at this intro to sequences, okay? So we started this and you're going to work a little bit at a time. So what we're going to do now is we're going to take a look at the first four because you should have gotten that far, okay? Then I'll have the teacher pause, give you some time to finish that section, and so on. So to find the next three terms, right, we need to figure out how this is growing, okay? So in other words, we need to find that common difference if it's arithmetic, or that common ratio if it's geometric. So 4 to 14 to 24 to 34 to 44, looks like we are adding 10. So 54, 64, 74, and so on. Okay. And so on. So now, oh my goodness, that bell just kind of rattled my brain, didn't it? Alright, I'll see if I can edit some of that out, so if you don't hear a bell, then you'll know I was able to edit it out. Alright, number 2, 3 to 15 to 75 to 375 to 1875. You may need a calculator to help with this one, which I am probably going to need, because it looks like 3 to 15 looks like we are multiplying by 5. Okay, so I can check that by going 15 times 5, which, yep, is 75. So, times 1875 by 5, and we get 9375. And my things weren't nearly long enough, were they? Times that by 5. We get 46,875. Times that by 5, and we get 234,375. Okay, so obviously number 1 is going to be arithmetic, 2 geometric. Found my common ratio, timesing by 5, common difference, adding by 10. Okay, number 3, we got 5 to 205 to 405 to 605 to 805, so it would be 1005 or 1005. Okay, 12,005 and 14,005. So our common difference, adding 200, which means it is arithmetic. So number 4, this one's tricky too, negative 8.7, negative 5.9. Okay, you may think, oh, it's got to be geometric because the other two were arithmetic. Okay, don't count that way exactly. So best thing you can do is start like this. Take this second number, subtract the first one from it. So I'd take 5.9, negative, subtract a negative 8.7, and I get 2.8. So I could be adding 2.8. If I wanted to check the multiplication, I could go that negative 5.9 and divide, oh my goodness, 5.9, divide by negative 8.7, and I'd get 0.67816092. And then I can check it going forward. Okay, and I always like to check the addition or subtraction first because it's easier. So is negative 5.9, if I add 2.8, that gives me negative 3.1. So this is another arithmetic, and we are adding 2.8. So then my next one would be 5.3, then 8.1, and finally 10.9. Alright, so check your answers. Hopefully you did it well, okay, because you should be able to figure these out. Now, for the next ones, 5 through 14, you are looking to see if they're arithmetic, repeated addition or subtraction, geometric, multiplication and division, or neither, if there's some sort of other weird pattern going on. By the way, if you didn't already know, this should be a 2 right here. Don't know why that didn't get printed off, but it didn't, okay? Alright. Have the guest teacher pause it, give you some time, work on these problems, get them done, and we'll take a look at them. Don't just wait for me to show you the answer, because that won't help you learn. Alright, so number 5. We start at negative 1, then we go to negative 4/5, then negative 2/3, then negative 4/7, then negative 1/2. Alright, so is there a pattern going on here? Well, if it was multiplication, that was weird, I'd have to times by 4.5. So if I go 4, or not 4.5, 4 fifths. 4 fifths times 4 fifths, -1, that would be -16 25ths, which will not reduce to 2/3. So I know it's not geometric. What about arithmetic? How would I get -1? What would I add to it or subtract from it to get -4 fifths, right? So what number, and I wrote that wrong, it should look more like this, right? What number would equal -4 fifths, okay? Well, I can take that 4 fifths and I can type it into my calculator, -4 fifths, and I can subtract a -1. And we can see what that gets us, right? So if I went -4 fifths minus 1, well, there'll be 1, that would be like 5 fifths, right? Okay. And I guess it would be -2, right? Common denominator would be 5. -4 minus a -5, that'd be like plus, that'd be 1/5. So if I take -4 fifths and I add 1/5 to it, will I get 2/3? -4 plus 1 would give me -3. 5 stay the same, -3 fifths. So this guy is a big fat neither. And that was really tough to figure out, wasn't it? Those fraction ones can be kind of super crazy. Alright, number 6. 10 to 20 to 10 to 5 to 5 halves to 5 fourths. Don't let this confuse you. We're dividing by 2, aren't we? Each time. 5 divided by 2 is 5 fifths. So that would be geometric. Number 7. 8 to 14. We would be adding what? 6. Add 6. Add 6. Definitely arithmetic. Number 8. 34 to 64. We'd be adding 30 to 94 to 1. Yep, another arithmetic, because we're adding by 30. Number 9, 2 to -10 to 50. Okay, when you see alternating from positive to negative, you definitely know it's not arithmetic. Could it be geometric? Yes, we could times by a negative number. So what if I times by -5? 2 times -5, -10, positive 50, yep. So we've got a geometric. Number 10, again, another alternating one. So timesing by a -4 would definitely work. Another geometric. 11, 4 to 13, we would what? Add 9. 13 plus 9 is 22, is 31, is 40, yep. Arithmetic. 4 to -24 to 144. Okay, it looks like it's probably geometric. Let's see, 4 to get to 24 would be timesing by 6. Make it negative. Is -24 times -6 144? It is, so another geometric. Okay, number 13, 1, 2, 6, 24. So timesing by 2 maybe? Timesing by 3, then timesing by 4, then timesing by 5. Okay, we're multiplying, but it's not geometric, is it? Because it's not repeated multiplication. It's multiplying by a different thing. So that is also a neither. Okay, this last one, 14. 9 fifths to 33 tenths to 24 fifths. Okay, notice we go from 5 to 10 to 5 to 10 to 5. There is a pattern there, okay? Unlike this one that didn't have a pattern. So there could be something happening here. So what if I went 33 tenths minus 9 fifths? So times by 2, right? 33 tenths minus 18 tenths. 33 minus 18 gives me 15 tenths, which would be what, 3 halves? So am I adding 3 halves? So 9 fifths plus 3 halves. Ugh, they'd have to both become 10, wouldn't they? So that would be 18 tenths and 6 tenths, which added together. Is that going to give me 33? Oh wait, times by 5. 15, huh? Derp. So 33 tenths, yep. Now go 33 tenths plus 3 halves. So times by 5 times by 5. So that'd be 15 tenths. Okay. I guess you probably should have just started out in 15 tenths. That would be 15 and 33 would be 48 tenths, which could reduce to 24 fifths. So yep, arithmetic. Probably just looked at that and thought, oh, that's neither, okay? But not always the case. So you've got to pay attention to that, all right? That was a tough one, though. All right, so now, next group, right? So now you're finding the common difference and then doing the three terms. So kind of what we did up here, more practice of that, but finding the common difference, which tells us if we're only looking for a common difference, these are all going to be arithmetic, okay? So pause the video now, take some time, work on these 6, and then let's see what you got. All right, so hopefully you figured it out pretty easily. Looks like we're adding 200 here. So our common difference would be positive 200. So it would be 839, 1039, 1239. Okay, number 17. Looks like we are subtracting 100. So our common difference is negative 100. So negative 406, negative 506, negative 606. Number 19, negative 23 to negative 18 to negative 13 to negative 8. You're adding 5. Okay, and again, if you weren't sure, take this one, subtract this one. That'll tell you what your common difference is. Or really take any of them and subtract from the latter to the next. Positive 5. So that would be negative 3. Then that would be a positive 2. And then 7. All right, 20. Negative 24 to negative 176. Sometimes looking at the first two, it's hard to tell. But when we look after that, we see again we're adding 200. So common difference is positive 200, 776, 976, 1176. Then number 18, negative 22 to negative 24 to negative 26. Looks like we're subtracting 2. So common difference is negative 2, negative 30, negative 32, and negative 34. Finally, 16, 28 to 23 to 18, that kind of looks a lot like 19, doesn't it? So this time we're subtracting by 5 each time. So common difference is negative 5. So this would be positive 8, positive 3, and negative 2. All right, so there's those 6. Now the last 6 are common ratios. So pick my color, very important. So common ratio tells us this is going to be geometric, then find the 3 terms. So now on these ones you're multiplying everything. So if you need help, take this term, divide the first term, that should give you what that common ratio is, okay? All right, but pause it, take a few minutes and get these last 6 done. All right, so let's 2 to negative 4 to 8 to negative 16. So we are multiplying by negative 2, aren't we? So our common ratio is negative 2, and this would be a positive 32, negative 64, positive 128. Number 22, negative 3 to negative 18 to negative 108. We should be timesing by a positive 6. I would just double check that. 18 times 6 is, yes, 108. So common ratio is 6. And then we'd go negative 648 to get negative 3888 times by 6. Negative 23, 328. And the last one, another ginormous number, 139,968. Okay, 24. Negative 1 to negative 5 to negative 25 to negative 125. We are definitely timesing by 5. Common ratio would be 5. Then let's see, I think I remember these ones. It would be negative 625. Then negative 3125. And finally negative 15,625. 15,625. 23, 1, 2, 4, 8. Definitely times them by 2. Common ratio is 2. 16, 32, and 64. 25 is the same thing, just the negative version. However, it's not going from positive to negative, which tells you you're still timesing by a positive 2, so common ratio of 2. So we have negative 16, negative 32, and negative 64. Then finally, number 26, 4 to 24 to 144. We are definitely timesing by 6 again. Common ratio is 6. And don't know where those numbers would be. 864 times 6 be 5184 times 6, 31,104 times 6, 186,624. Okay, so you guys should be all done with this. Hopefully you did really well. If not, hopefully you spotted your mistakes. Get this handed in, and we'll go from there. All right, guys.